What'd you think about the quiz, folks? Tough? A lot like homework? Most of them? No, maybe. Find out when you get your grade back. You'll know how you feel when you get your grade back. That may be what's maybe the better option there. All right, so section 3.2 is where we're at today, and in 3.2 we're going to talk about the graph of a function. Basically. And that air conditioner is not working at all today. All right, so there's a lot of information in that one little graph that you got there that can go on. Now, how do we know that's even a function? What's the first thing we've got to do to decide that's a function? The vertical line test. Yeah, to decide if something's even a function, you check it with the vertical line test. If you got a graph, if it's a set of ordered pairs, you look for no repeated x's, that sort of thing. So if you got an equation, one of the best things to do is graph it. Is it a function? And vertical line test is how you can tell that. So we know that passes the vertical line test easily, right? Okay, so that means it's a function. Now, what are all these little things here? These dots and the numbers beside them. They're ordered pairs, right? Now, some of them got pi and 3 pi over 2 and stuff, but those are just numbers. They're just weird numbers, but they're numbers, right? Okay, so we get some information from that graph. That the blue line, what does it represent? Is it ordered pairs too? Just doesn't tell us what they are. So I'm thinking the ones that they've marked here are the important ones. That's kind of what happens here. When they give you a graph and they want you to do some of this stuff with it, they're going to give you the important points, or at least this is going to help us know where the important points should be. So we notice right here, where is this point at and why is it important? 0, 4. Where's it located on that graph? If I had to tell what quadrant it's in, or maybe it's not in a quadrant. It's on the y-axis, and y-intercepts are important, right? When we did slope-intercept form of an equation, we had the y-intercept there. So that makes that an important point. So that's one of the things that could be important. Where are these points? The X intercepts, that's a very important thing. Like in Algebra 2, you spend a lot of time working on how to find the X intercepts for polynomials. Those are important points, okay? Well, what's so important about this point, and this point, and technically those two as well? What happens to the graph at those places? The highs and the lowest peaks. That's exactly right. Okay? Those are important points. So when you look at a graph, you're looking for those important places. X and Y intercepts. Highest and lowest peaks. Okay? You're looking for those things. Those are important parts of a graph when you look at it. So when you start looking at a function's graph, whether you've got the equation or not, I want you to start thinking, hey, what are the important places of this graph? I know there's a line that's drawn here, and it may curve, it may not, but what are the important places? And when you look at it, this graph has a lot of those, and that's why I like using it to introduce all this stuff, because it's got a lot of stuff in it. Okay, so you got y-intercepts, x-intercepts, you got lowest points, you got highest points, and then we got a few other things we're going to learn as we go here. Okay, so with that, based on this graph, we could, we'll just call this example A. We're just going to do some work with it. I'm going to ask you a bunch of questions about it, and we're going to figure them out together. Okay, so we got this graph. Notice that it doesn't have an arrow pointing to the left and an arrow pointing to the right or up or down. It ends here and here. So it's just this one little section of this graph that we're looking at. Okay, so with that, being said, let's start answering some questions. All right. First question I want to know is, what is f of 0? for that graph? What's that even mean? It's function value, but I don't have an equation to plug this into, but I got a graph. What does f of 0 represent? Remember, f of x is the same thing as y. So f of 0 would be the y value when what? When x is 0. So f of 0 means what's the y value when x is 0? So when we look at our graph that we got, x is 0. That would be here. Go to the origin. Look for where it's crossing the y-axis. It's 4. So f of 0 would be 4. Same kind of question, so I'm going to keep it on number 1 there. What's f of 3 pi over 2? So I'm looking for what am I looking for in this graph? The y value for what x value? All right, so I'm just looking for where's 3 pi over 2 on this x here. Right there. So what's the y value? 0. Okay? So you can find pieces of the graph, we can do function value just from the graph. That's not normally how we've done it all through high school. We give you the function equation and say find f of this. And you have to go plug that in and do the math. Because we want you to practice order of operations. We want you to practice evaluating expressions, that sort of thing. So here, what we're trying to tie together is that idea and a graph. They go hand in hand. They exist together. Okay, so function value goes to a graph. It's the y value for a particular x value. Okay, so question number 2 for this problem is what's the domain? I'm looking for the domain of this guy. So you got to think about what has he said about this graph. He said, well, okay, a while ago he said that it didn't have an arrow on each end. So that means it stops. It's just one particular section. What does domain deal with? The x values. So what's the lowest x value? 0. Is it included? How do I tell on a graph if it's included? What if it? Well, not necessarily that it doesn't have an arrow, but that dot is filled in, right? If it wasn't included, what would that look like? Be an empty circle if it wasn't included. Okay, so our starting point's at 0. So our domain, we know, is going to have a 0 here. And what beside it? Parentheses or bracket? Bracket, because we're including that 0. And then we look and say, okay, how far does it go to the right? So we read it left to right. So what's the furthest x value to the right? 4 pi. So the x value, 4 pi, which is just 4 times 3.1459, all those numbers there. It's a number. Okay, so that 4 pi is where we're going to. Is it included? If we look at our graph. Is it a filled in dot? Yes, so it is included. So that means it should have what beside it? Bracket. Good. If it's an empty circle, that's where you're going to have the parentheses. Okay, so when you look at these graphs, you're going to see filled in dots. You're going to see empty circles as well. Understand, one means a bracket, one means a parenthesis. Okay. All right. Now, next question. We said domain. Let's go ahead and say, what's the range? What is range when you start talking about a graph? The y values. Okay, so y values go which direction? Left, right, up, down. They go up and down. Okay, so what's the range of this one? What's the lowest y value? -4. So I go down here, and this is where, Megan said the high peaks, the lows, and the highs. That's where those are important points because it helps us find that range. Our lowest points here, this one's got a -4. This one just happens to have the same y value, so that they're tied for the lowest. And then you go up here, and your 4 is the highest all the way across there. So our range would be from -4 to 4. Brackets or not? Yes, because they're part of the graph. They are included. All right, good, not too bad. So far, we hadn't got out of Algebra 1 stuff. We talked about domain and range in there. We just got weird numbers here, so we have to look at that graph and not have to assume anything. All right, so the next question is, what are the intercepts? Okay, so what kind of intercepts are we concerned with? The X intercepts and then the Y intercepts, or Y intercept for this one. So we look at that graph, and we'll get the one that the easy one first. What's the Y intercept? 0, 4, right? The ordered pair, 0, 4. Okay. So here's where people start to get confused in this particular section. Is this interval notation or an ordered pair? Ordered pair. When you start doing your domain and range, it could look like an ordered pair, but it would be interval notation. Okay? Be careful to know the difference in the two. If I'm talking about intercepts, they always have to be what? Ordered pairs. If I'm talking about a range of values, then I'm talking about interval notation. Okay, so interval notation deals with domain range. We'll talk about increasing and decreasing in a second. Those are intervals, but intercepts are always going to be points, ordered pairs. So be careful of that. I always have that problem in this section. Okay, so the next thing we want to do is get the X intercept. So when we look at that graph, man, how many are there? There's 4 of them. What are they? Pi over 2, 0. Okay, 5 pi over 2. That's one of them. Jumping out of order, but that's okay. I don't care. 3 pi over 2, 0. And then 7 pi over 2. 0. So those are the places it crosses the x-axis. That's what we're looking for. Okay. Trying to find where it crosses the x-axis for those intercepts. Okay. Y-intercepts, X-intercepts, very important points when you talk about a function. Okay. Question number 5 for this particular graph. Now this is stepping up the game a little bit. How many times would y equals -2 intercept the graph? Interesting question. Kind of comes out of left field. Not real sure where it came from. I don't know what y equals -2 has to do with the graph that I've got, but maybe it's important for whatever situation it came from. This graph is like Hunter said, it's a time graph. It could be sound waves, and we're looking for when is the decibel level at -2 in that that graph. And the sound wave does make that kind of graph. So, what does that mean we need to know how to do? It means I need to know how to graph y equals -2. Well, if I go to my graph, you're looking at your graph there, where is -2 on the y-axis? So -2 would be right there. I kind of got a dot already there to kind of lead us in the right direction. Okay, what does that line look like? Horizontal. right? Y equals the numbers horizontal. So this is what it looks like. That's y equals -2. How many times does that cross? 4 times. 1, 2, 3, 4. Doesn't ask what the crossing places are, just asks how many times. Okay? If we needed to know those points, we'd have to know a little bit more about this function, really, honestly. You know, what's the equation? That could help us get those points exactly. So it's 4 times. It's not a seems like a weird question, but it is valid. They're going to ask questions like that. So question number 6 about this same graph. Where is f of x greater than 0? What? What does that mean? What's that asking? All right, I heard 2 different answers. Stormy, what'd you say? What'd you say? Which one is it? Y. Why is it y and not x? Because f of x is y. So it's asking, when are the y values greater than 0? Where are y values greater than 0 on the graph? Up at the top, above what? Above the x-axis, right? Okay? So anywhere the y's are positive, that's what we're looking for. All right? Now, here's what we've got to report. We're looking for y values. When it asks us where on a graph, when you talk about going somewhere, usually traveling by car for us here in rural West Tennessee, you don't go by air, right? You don't go in the Y's. You go by land on the X, okay? So if you're going to tell me where that is, where means give me the X values, the intervals on X values, okay? So when it asks for where on the graph, we're thinking X values when we're trying to report where is it positive. So the first place, if I look at this graph, you know, I'm going to read it left to right and just go that direction because that's the way I learned how to read. Okay, left to right. So here we've got starting here at 0. That's a positive y value, correct? It stays positive until where? Till it drops below the x-axis. So it drops down to the x-axis right here at what important point? That pi over 2, 0, right? That's an X intercept, right? So that's why those are important points again. So our first interval where that is positive would be bracket from 0 to pi over 2. Now here's the kicker. Thank you. It's okay. All right, so is there a bracket or parenthesis right there? Why? Right answer, wrong reason. Brooks, she's like, my brain is turning, I can't figure it out. Why is it a parenthesis? We know that's the right thing, but why? Go ahead. All right, try. Seth, go ahead and say what you were going to say. It's okay to be wrong. Okay, what is it though? It's 0. Is 0 positive? It's not positive or negative, right? So it goes right up to that place. Just right to the left of pi over 2, it's still positive. But once you get to pi over 2, you're at 0. You're not positive anymore. You're in between. Okay? So that's why it's a parenthesis, because the y value there is 0. Our inequality doesn't say equal to 0. It says greater than 0. So that's important. Okay? I think you guys kind of knew that. You just, I'm scared to say it. Okay? So when I look at my graph some more, I got to go a little further. All right? So I got to here. All right, all the y values right here are what kind? They're negative. So, all right, right there. 3 pi over 2. That's an important spot. Parenthesis or bracket? Parenthesis. Same reason as the parenthesis on the pi over 2. The y value right there is 0. And I keep going on my graph. It's positive until we get to where? Yeah, the next x-intercept, 5 pi over 2. Then what? 7 pi over 2. Included or not? Is it included? Remember, what are we looking for? Y values that are greater than 0. What's the y value with 7 pi over 2? It is 0, so it's not greater than 0. So we can include it, so we're going to use parenthesis. And then the next x value that we get to here is 4 pi. Now, is 4 pi included? Is the y value that goes to 4 pi positive? Yeah, so we can include that guy. And we don't have any more because our graph ends right there. It's got a solid dot at the end, no arrow, so it stops. Okay? It's a good thing because this thing just keeps doing that the rest of its life. Okay? So, now. Yes, sir. Paragraph. Does what's happening change at 2 pi? Because our interval there that 2 pi is part of is from 3 pi over 2 to 5 pi over 2. All right, so when I'm looking at that piece, all the y values starting at 3 pi over 2 are positive. At 2 pi they're still positive, right? They're still positive until I get to the next one. Okay, so when I report that interval, I don't need to tell every one of them that's positive. I need to tell where's it change at. That's what I want to get there, and that's an important thing. It's a great question. Why not include that point? Well, if I was going to include that point, I'd have to include every one of those on the blue line, and that's a little too much. You couldn't include them all because there's an infinite number of points on that blue line. All right, so you're only reporting when something changes. Okay, all right. Next question. Notice I'm using interval notation, and you guys aren't freaking out. That's awesome. Makes me feel good. Okay, you're gonna get better at it. Okay, I promise. If you don't feel comfortable with it, you're gonna get better at it. Question number 7 about that same graph is where does f of x equal -4? Question mark. Where does f of x equal -4? Pi and 3 pi. Again, ask the question where, so what are we reporting? X values. We got a y value equal to -4. It's at x equals pi and x equals 3 pi. I don't know why I wrote my pi's very straight. They usually should have a little squiggle to the top there because it's lowercase pi. There is an upper and a lowercase to the Greek alphabet if you didn't know that. You will when you go to college and you go to Greek society. So that's lowercase pi. Uppercase pi does mean something else. All right, so what are some other questions they could ask me that are related to the ones that are here? Well, they asked us where f of x was greater than 0. They could also ask me where is f of x less than 0. It's going to be done the same way. Like we have to go through that. You would think, okay, that means where the y value's negative. So your interval would be from pi over 2 to 3 pi over 2, and then the next one would be from pi over 2 to 7 pi over 2. Those would be the negative intervals for that. Okay, so we get intervals where y values are positive and negative out of that thing. Okay. Let's look at what if they don't give us a graph and they start asking us a bunch of questions about it. So Example B. Finally getting away from that graph I handed you and going to another problem. F of x. And let's get something familiar, kind of like what we did yesterday. Maybe we got this function. Okay. They're telling me it's a function. Maybe I know what it looks like as a graph. Hopefully from Algebra 2 you remember, oh, there's some stuff that does. Or at least we know how to type it into a graphic calculator and get it to draw it. All right. Okay, so let's answer some questions about it. To relate back from the last couple of days, what's the domain? Okay. How do we find the domain today? Yeah, we got a red flag there. We got the x in the denominator. So, yeah, we said x plus 2 equal to 0 and get x equals negative 2. So that means our domain in set notation would be x does not equal negative 2. What is it in interval notation? Okay. To a negative 2?
Yeah.
And then, yeah. Okay. Awesome. Good job. Yeah, perfect. Always going to be parentheses on the infinities, and then we're skipping negative 2, so we've got to do parentheses on those. So good job. Good job. So that's the domain. We can find that without even graphing it. Okay. That's handy to know. Here's another question. Is 1, 1/2 on the graph? What in the world? What does that mean? Plug what in? Okay, I like that idea. F of 1 would be 1 plus 1 over 1 plus 2. So that's 2 over 3, which is not 1/2. This does not equal 1/2. So the answer to that would be a big old no. How else could you do that? We always try to find alternative methods to solve things, because that's what good thinkers do. Yeah, absolutely. Graph it on the calculator. So if I grab my graphing calculator, maybe we want to practice drawing that graph or getting that typed in correctly. Maybe we hadn't done that in a while. So what do you have to do when you type that in your calculator? You might know. Something very important that you should do. Grouping symbols, absolutely. Whether you use parentheses or brackets, I don't care which one you use as far as that goes. All right, come on, you calculator, you. There we go. Go to y equals. This is some stuff from my class last night, so I'm going to get rid of that. Parentheses. Got x plus 1 on top. Close the parentheses. Divided by parentheses x plus 2. If you don't put those parentheses there, it's going to mess it up. Awesome. That's a cool looking graph. It's weird. We're going to get to where we do a lot of work with these this semester. We'll figure out a lot of things about why does that look like that. Okay, so he said we could graph it on the calculator and decide if 1 1/2 was on there. So I could hit trace and type a 1. And if it's on there, I should get 0.5. I don't get 0.5, I get 0.66 repeating, which is 2/3, what we found when we did it by hand. So we know that point is not on there based on that. So two different methods to solve that. One's quick, one is not as quick, one's easy, one is still easy. So it doesn't matter which way you do that. But know that those are options to test those things. Okay? So great. Question number 3. Where is f of x equal to 2? Huh? Uh-oh. What do I have to do here? I don't know what to do. What do I do? I have my function. F of x is equal to x plus 1 over x plus 2. Where is f of x equal to 2? Math-wise, what do I do? Plug in the 2 where? For y, y is the same thing as f of x. So I really have x plus 1 over x plus 2 equal to 2. It's equal to y, so I'm going to set it equal to 2. Now, how do I solve that? Maybe that makes it easier. Makes it more Algebra 1-like. Yeah, cross multiply. Bottom times top. Bottom times top. That'd be 2x plus 4 is equal to x plus 1. Subtract x. Subtract 4. X equals -3. And remember, it asks where. That's an x value. That's what I found. I found x is equal to -3. So that tells me where y is 2 is at -3. And how can I verify that for sure? Yeah, we already got it graphed on the calculator. So if I went back to that and I typed in, I hit trace and I typed in -3, I should get a y value of 2. And I do. So that works there. So there's a verification of that. Maybe it's not easy to find using the calculator, but it is easy to verify with the calculator. Okay, that's a good thing. All right. Let's get to the important points. What are the important points? These are some of them. What are the intercepts? The x and y intercepts. So we got x intercepts. We got y intercept. We've already seen the graph of this thing. So we know it's crossing the x-axis. I can see that. It's crossing the y-axis. I can see that. How do you find those? Well, I could hum-haw around here on the calculator until I got where I thought was close. But how can you do it in an algebra class? Hey, I'm teaching right now. I see me during skinny. That's all I can tell you. All right, so x intercepts. How do we find x intercepts? What do we know about x intercepts? Set the y is equal to 0. So that means x plus 1 over x plus 2 equal to 0. And then that's a lot like what we just did for question number 3, right? Cross multiply. Works out real nice because I multiply 0 times x plus 2. Yeah, to be x plus 1 equals 0. And that gets us x equals -1. So the x-intercept's at -1, 0. So that's that point that we saw on the graph where it crossed. I think we could have got that one with the graph, but not necessarily always going to be able to do that. Now, how do I find y-intercepts? Yeah, y-intercepts are where f of 0 is at. So that'd be 0 plus 1 over 0 plus 2, 1/2. 0, 1/2. It's the y-intercept. And again, we can verify that with our graph on our calculator. That's a handy thing to do. Yeah. Yeah, we do a lot of the same things again. We'll get to more intense functions soon. This one's not too bad. All right, so good to know that. I'll ask you about all the different kinds of questions I can think of here for this particular section. Okay, so what I would want you to work on, we're finishing a little bit earlier than scheduled because you guys knew all the answers. That's a good thing. So the suggested problems for this section. On page 224, numbers 9 through 47. And I suggest the odd, that way you can check them in the back, but you can do the even ones and then check them with my book. That's fine. It's fine with me. Okay, so